Okay, so the second example we have for the week number 5 is going to be about a plate that has dimension of 0.4 meter by 0.4 meter, as you can see in this diagram. Okay, so the width is 0.4, the height is 0.4, hinged at the point A and supported at the point B. Now, what's happened if we're going to remove the support at B suddenly? We need to remind what will be the reaction at the point A if the mass of the plate is 30 kilogram, which definitely going to have the location at the center. So that's a free body diagram. That's kinetic diagram, as easy as that. So um, we're going to do the analysis of this one, and you will see that it will be not going to be that complicated. So once again, the center of the graph is going to be in the middle, and the no support at B is going to be removed, and we are going to have the X and the Y direction forces at the point A. Because that's located in the center, so the height from the point A is going to be 0.2 meter, and the on the x is going to be 0.2 meters, so we can find the length of the r GA. We can find it as a vector, and we can find it as an ordinary number. So at that point, as the link is going to be sketched between the A and the G, we're going to have tangential force and we're going to have normal force. And we're going to do the calculation to get this figure as shown here. So let's go to the next page. Initially, that's the answer. Initial omega was equal to 0 because it's just start from the static location. So we can calculate the IG, which is the mass moment of inertia, which is mainly in that shape. It's not going to be rho, so it's going to have the height and the width need to be considered. Then we can calculate the sigma of the force to the x-axis, the y-axis, and the moment around the point A. And we're going to solve to find the value for the alpha, the AX, and the AY. So let's see how we're going to do that. Again, that's a free body diagram, and that's with the kinetic diagram. And what we need to do is just link the point G and the A to have a link. And on that link, we're going to have tangential and normal accelerations. Now, what's given to us is that the mass 30 kilograms. We know the omega is equal to 0. We need to find the alpha, the AX, and the AY. So we start with the step number 1, which is, just give me 1 second, I need to change something here. Okay. What is that? I think that I just need to change something. So, sorry, on the same. Okay, so. Okay, doesn't matter. Okay, so, yep, we are going to go to the next page here. Okay, and you'll find actually that actually that's shown up here, no problem. Similar the force, the x-axis, the y-axis, and the around the acceleration about the moment around the point G and the point A. We're going to do both, and you will find actually the answer is going to be the same. So now we are going to go to the calculation of the IG for the square shape. It's going to be 1 over 12 multiplied by the mass multiplied by the width square plus the height square. So we're going to get the answer to be 0.8 kilogram cubic meter. We're coming to the accelerations. The normal one is going to be equal to 0 because the omega is 0. And then we're going to have the tangential one is going to be alpha multiplied by the RGA. So the RGA, if I'm going to use the Pythagoras equation, is going to be 0.2 square plus 0.2 square under square root, and this will be equal to 0.282 alpha. Now we're going to calculate the AGX, which is going to be the AG multiplied by the sine of 45. Actually, I need to sketch that for you. Sorry if I missed that. Okay. Now, we said that this will be the X and this will be the Y. Now, that's a 0, but that can be divided into two components, which is going to be, this angle is 45. So it can go to the x-axis and the y-axis. So this one, the x-axis is going to be the AGT multiplied by the cosine of 45, and this one is going to be by the sine of 45 for the y-axis. Okay, so we can find both, and in both is going to be going to the left and going downwards, so it's going to be negative 0.2 alpha. Okay, so now from here we're going to start to do the calculation using these parameters. Going to the equation number 1, the AX is going to be the mass multiplied by the AGX, and this will give me that the AX is going to be equal to negative 6 alpha. We knew that. Now we go to the y direction, and here we're going to include the weight. So the weight is minus 30 multiplied by 9.81 plus the mass plus the AY is going to be equal to the mass multiplied by the AGY. So again, we're going to have the answer to be minus 30 multiplied by 9.81 plus AY is going to be equal to 30 multiplied by the 0.2 alpha, and this will be equal to 22.5 alpha. Now we're going to solve for the moment around the point G. So we're going to have the AX multiplied by the distance from the A to the point G in the y direction, because we're going to have the force we said is going to be acting here. Sorry, we're talking about this one. So this one is going to be perpendicular to that distance, the G to A. And for the force AY is going to be perpendicular to that distance. So, that's 0.2, as you remember. So we know these values are going to be 0.2. The AX is equal to, you can get it from this equation. By rearrange that equation, the AY is going to be equal to 22.5 alpha plus the 30 multiplied by 9.81. Okay, so we can find the AY in terms of the alpha, and the RG has been calculated and the alpha is unknown. So I can put everything in this equation and solve for the value of the alpha. And we can find the answer actually. If you're going to substitute negative 6 alpha here, and the AY is going to be the 294.3 minus 6 alpha. Okay, and this will be equal to 4 alpha. You will solve for that and you'll find the value for the alpha. The other way we can do it is around the point A, and in that case we're only going to have the AG alpha and the mass multiplied by the AGT multiplied by the RGA, which is that force multiplied by that distance, because it's perpendicular to it. This seems to be much easier, so I'm going to simply put all the parameters in, and I will solve for that. I will get the alpha 18.4. Actually here, if I'm going to consider that, at the end we're going to have something like the 294.3 divided by, we have minus 6 alpha, we have another minus 6 alpha here. Sorry, yeah, we have another minus 6 alpha, so this will be negative 12 alpha. We're going to take it to the other side, so it's going to be 16 alpha. So if the alpha is going to be equal to 2943, the 0.3 divided by 16 is going to be the same answer as 18.4. You can try that yourself. Now we have the alpha value. We can calculate for the AX and the AY directly by substituting the equation 1 and 2. So once again, I think that I told you about that earlier. No matter how complex the shapes look like, in the end you will find out actually it's going to be quite simple to be solved. Just work once again, it's stress-free. So there will be another question to be covered. I'm going to make a video for it very soon. And